Hello everyone, my name is Subham, and in this video we will discuss a very good concept in number theory, that is congruence modulo M. So to start this topic, I will give a small motivation. And what is my motivation? See, if I ask you, give me two number such that if I divide those number with 5, then they will give me same remainder. So I taken one number, say 7. Now if 7 is divisible by 5, then remainder will come as 2. Now if I take 12 also, then if I divide with 5, then what will come? Remainder is same here also. So what is happening here? So we are taking two numbers 7 and 12, and when we are dividing with 5, it's giving same remainder 2. So in such a situation, we will say that this 7 and 12 are two integers which are congruent modulo 5. So we will write the definition first, congruent modulo M. So this is the first definition that I will give, right? So two integers are said to be congruent modulo M if they have same remainder when divided by M, right? So what is the definition? Two integers are said to be congruent modulo M if they have same remainder when divided by M. So here 7 and 12 are two integers and 5 is a natural number, right? So when we are dividing this 7 and 12 with 5, they are giving the same remainder 2. So 7 and 12, I will say that they are congruent modulo 5. So here there are some restrictions on M, that is M belongs to natural number. Is this fine? Is this fine? Okay. So this is the definition, one of the definition of congruent modulo M. Now I will give one activity, right? This activity will help you to understand this concept very clearly, right? So suppose I taken my M is equal to 5, right? Then what are the remainders? If you divide a number with 5, then either remainder 0 will come, or 1 will come, or 2 will come, or 3 will come, or 4 will come, right? Now what I will do, I will write all integers which when divided by 5 then give you remainder 0. So these integers are nothing but this set, that is minus 10, minus 5, 0, 5, 10, 15 and so on. So this set I am saying 0 group, right? Why I am saying 0 group? Because any element if you take from this set, any number if you take from this set, then when you will divide with 5, it will give you remainder 0. Now these are the integers, when you divide with 5, then it will give you remainder 1. So I consider this all element as one group. And if these numbers are divided by 5, then it will give you remainder 2. So I considered all those numbers as 2 group. And similarly for 3 group and 4 group, right? Now if you take any integer, then that integer will lie in any one of the group, right? Got or not? Now what will happen? So from the same group, if you take any two number, then they are congruent modulo M. That is we defining, right? We are defining two integers are congruent modulo M if they give the same remainder. And here that is what happening. Here if you take two elements from the same group, then what will happen? They are congruent to each other with respect to the M value. So here with respect to the value 5. Got or not? So this is the activity to get the feel of the topic, right? So now we will move for some small questions. Say these numbers you have to collect in the same group. Like when you are dividing this number with 7, then those numbers which are giving same remainder, they will be together, right? So you have to collect those elements which have same remainder when divided by 7. So this is homework for you. You can try. So these are very basic things, and I hope you understanding these things. Now we will move for little bit more generalized definition of this topic. So the formal definition, if I say for congruence modulo n, is what? So for a positive integer m and integers a and b, we say that a is congruent to b modulo m if m divide b minus a, and this is denoted by b is congruent to a modulo m. So what is the definition? So again we have to consider one positive integer, say m, and if we have two integer a and b, then we say that a and b are congruent to b modulo m if m divide b minus a. So denoted by this. Now see, if you remember the previous activity, then what I am saying, that if two numbers are from the same group, then they will be congruent modulo m. So suppose a and b are the element from the same group. So a can be written as mx1 plus r, and b will be also written as mx2 plus r form, right? Why? Because a and b will give same remainder. That's why I written r here, and it has some quotient. So this is by remainder theorem, right? Now what will come? B minus a. B minus a will be nothing but m into x2 minus x1, and clearly it is divisible by m. That is only we are saying, got or not? This is very easy, right? And I hope that activity will help you to understand this one. So see the definition, how nicely it is written. So I hope you understand these things, right? And you have a nice feeling of this topic. Now we will give some questions to identify that they are congruent modulo m or not. So this is the question, and this is very basic question. So we have to mark that it is true or false. So see, this meaning is what? 17 is congruent to 27 modulo m. So it is true if 17 minus 27, that is nothing but minus 10, is divisible by 5, and actually it is happening, minus 10 is divisible by 5, so this statement is true. Similarly you have to find for the rest 3, right? Now we will move for the next one. So in the next question we have to fill the blanks. So here 19 is there, and suppose a is my required one. So if a is my required answer, then 19 minus a will be divisible by 6. Now what should you take the value of a so that it will be divisible? So if I take a equal to what? 1, then 18 will be divisible by 6. If I take a equal to 7, then 19 minus 7 also 12, and that is divisible by 2. So there are many. So you write all pattern, right? Similarly you find for the rest 2. So these are some basic problem on this topic. I hope you are getting this. See, some nice problems we will do later, but first we will learn the theory part, and then we will do good problems. So now we shall move for the properties of this congruence modulo m, and we will give the proof of that also. So if you interested on the proof, then continue, otherwise you skip those parts, right?